Okay, so just to start off with, what we're going to do is do a brief overview of Project Otosukeru, or Auto Proxy Deployment, leveraging infrastructure as code with Terraform, PowerShell. So this project's up on GitHub at the moment. It's up on the address that you can see here. What I'm going to quickly do, go through a bit of the structure, show you the actual code itself, and then run a few examples of how to actually make it deploy the proxies automatically, how to scale them, how to deploy a NAS proxy, and effectively then finish off with how you integrate that into a Veeam Backup job as well. So just to start off with here, you can see, obviously on the screen here, you've got all the files that are part of the project. The project README is listed down here, and it's got a fairly detailed description. The requirements, important to point out that from Terraform for the moment, we're going to stick with version 11x. Version 0.12.x has got a few issues that I've got to iron out in the bugs, but effectively all those are downloadable. So when you actually download or clone it from this repository, it won't have the terraform.exe, as you can see here. So you have to download that and basically put it into this folder, which is the proxy Windows folder, and also put it into the proxy Linux folder as well. So download terraform.exe, put it in here, and that's all you have to do from that point of view. Just again, going through the actual structure very simply, we've got the main PowerShell script and a couple of configuration files. I've also included a post and pre-batch script, which I'll get into a little bit later on, to where that's actually quite useful. And then a couple of output JSON files as well, but that basically doesn't need to be touched. If we look here in terms of the configuration, we've got a bit of a changelog to see how it's evolved from when I first released it, and the additions that I've put into it since then. It's got a bit of a getting started in terms of how you actually run it, the parameters and what they do, and then some examples in terms of how you actually create and configure the proxies, create a NAS file proxies, how you can actually set the count to scale up or down. More recently, I added the ability to add a work group. By default, it's going to add the proxy, Windows proxy, to an Active Directory domain, and then a few bits and bobs as well. Configuration-wise, there's effectively 2 to 3 configuration files that you need to look at. The actual main PowerShell script itself doesn't need any touching. It's basically as is. It'll go and source variables from here. So if we have a look at the configuration, really what we're doing for the Linux proxy, we're giving a username and password, depending if you're going to deploy CentOS or Ubuntu. It's pretty self-explanatory here. Username and password. You don't need to put both in, obviously, but it's just basically set here for default. The point of view of the VBR server, you actually don't need to put in that because you're running it on the actual VBR server itself, but it's good to have just in there just in case. And then a username and password that relates to Active Directory domain join. So an account there that's got Active Directory privileges, domain user privileges, enough to actually add the proxy. And then if you're doing a work group, this is the username and password that gets created as part of that automatically. So you don't actually need to change that, but it's always going to be that as part of the deployment script. In terms of Terraform, this is where you do have to put in a few things. Again, putting in the vCenter connection and password. This is the crux of it though, the biggest area that you do actually have to put in. So depending if it's a Windows proxy or a Linux proxy, effectively fill out the details in the respective Terraform folders in the TF files there. So if we have a look here, we're really just talking about details that are specific to your own vCenter. So data center name, folder name, resource pool, the template that you want to use. It's an important thing to note here that at the moment you've got to bring in your own template. So you have to basically create your own Windows 2019 template, 2016 template, server core or GUI, or for Linux, you will create your own CentOS or Ubuntu template. And I do actually list in the requirements here how to actually get those configured at the same time. So it's pretty much important to get them deployed correctly, but for all intents and purposes, a default situation will suffice. So let's take a look at the code in Visual Studio. So if I open this up, we'll minimize that to start with, and that's our vCenter that we're going to deploy it into. If you take a look here, you can see that we've got the main PowerShell script here. So let's still deploy Otosukeru. And for a side note, Otosukeru actually is Japanese. Doesn't mean anything. It's actually nonsense if you were to actually say it to a Japanese person. Auto means auto, and Sekiro means scale. So basically auto scale. So that was basically the sort of genesis of that particular project name. So if we have a look here, effectively you can see all this code here is the logic that is going to drive the actual deployment itself. PowerShell is used to call Terraform. You don't need to do anything in here. Again, this is all set in stone. It's going to call the config.json again, which is what we've already shown you guys here. And then if we have a look at the folder structure, you can see that we've got the proxy Windows, proxy Linux. This is basically here, so if we minimize that, that's what it looked like. If we maximize it out, you can see we've got proxy Linux. All you have to do is effectively go and change the terraform.tf vars file. And again, it's got all those details in there that you need to put in, very self-explanatory. It's a little bit fiddly to start with, but for those that have played with PowerShell and vCenter before, it's pretty standard in terms of what you're adding in. If we have a look at the Linux, the only other difference apart from the Terraform.vars that you need to fill out is this maps file. And this maps file effectively is a good way to get Terraform to look at maps of variables, and then depending on a particular parameter that you use one or the other. In this point, it's obviously looking at Ubuntu or CentOS. It does a couple of different things. The main thing that you've got to put in here, though, is the template password and username. And then over here as well, you've got to turn the location. So where else in the Windows version, you're basically looking here to set the template location for Linux proxies, which I think this is great. I think it's a great use case for. Effectively, you do it in the maps.tf file. Now, let's see it working. So over here, you can see I've got a Veeam Backup Replication server. It's actually got no proxies listed. We've got the default one here, so the default VMware Backup Proxy, and then we've also got no real managed services apart from the default ones that we're using in a connected vCenter. So once you're ready to do a test run of the deployment, you can go to the folder. Once you've edited and got all the parameters and variables in place, what we can then do is run a deploy Otosukeru.ps1, and it's got a bunch of parameters that we can actually run on the actual script itself to tell it what to do. So, what we're going to do here is we're going to run a Windows box server. We're going to do a set proxy because we're going to tell it how many proxies we want to use, and let's do it on the work group as well. So let's make it a bit quicker. So when it actually goes to execute, it's going to go through the PowerShell. It's going to understand what you've actually chosen in terms of your particular variables. In this case, Windows work group and 2. It's obviously calling Terraform here. Terraform is now going out and actually going to deploy these machines to vCenter. So let's take a look and see what's happening in vCenter. You can see we're cloning a couple of machines. These are the machines here, the VMs. So they're being cloned, they're given unique names. There's a randomizer as well to the name. So if you want to actually execute this for different jobs at different times, you won't get an error saying that the VM name is in use. So we've got a randomizer in place which names it as such, and a Linux machine would look like an L there instead of a W, just to indicate that it was actually a Linux box. So this is all being configured. This is using guest customizations to do a lot of the work. Depending on the speed of your storage, that's really what's going to dictate the actual deployment time for those particular templates. So, in this particular environment with some, average storage, we're looking at about 2 minutes, 2 minutes 30 to 3 minutes to deploy these two. So let's come back when it's done and we'll show you what actually happens at the end. Okay, so you can see that the machines are created. Terraform has finished doing its thing. We actually then, at this point, are exporting those JSON files. That's being fed back into the PowerShell. And the PowerShell now is actually connected to the Veeam Backup Replication server and starting to configure these servers up in there. So in a few seconds, what we'll see is we're installing the transport package that we need on the actual Windows machine itself. And it's going to appear here under Managed Servers very soon. So let's wait for that one to be put in. That's the first step. So we first install that management pack to effectively bring it under management by the Veeam Backup Replication server. It's going to collect all the information. And the second part of that is to actually configure the proxy role on that server itself. So you can see it's popped in there, and now we've basically gone and said it's configured. If we go to the backup proxies itself, you'll see that we've got 226 in there as well. And at the end of this particular run here, so when we're uploading the Veeam transport, it's installing the package, and 226 will be joined by 227. Okay, so This is really just standalone. It's doing it itself. Within 4 or 5 minutes, you've basically deployed the Windows server, you've configured it, put it on a work group, and now you're adding it to Veeam Backup Replication, effectively ready to be used as a Veeam Backup Proxy. So you can already start to see the power of this particular solution. So there we go. Okay, adding there, create a new Veeam Backup Proxy. So there's both of them. So we've got 2 of them in there now. So that's done. That's it. Both configured in 4 minutes and 85 seconds, under 5 minutes. We've deployed and configured 2 proxy servers. Now, just to show you a bit of the scalability, because like I said in the blog post and in the intro, this is really about the auto-scaling of the Veeam Backup Proxies. It's an automatic deployment, but for me, it was more about the auto-scaling, okay? So what we can then do, if we want to auto-scale this up or down, it's basically the same commands, but if we want to go to, say, 3 proxies now, we just effectively replace 2 to 3. So we can go up and we can go down. 2 is actually the minimum that it will deploy, so we won't deploy 1. So you're going to be deploying at least a minimum of 2. Maximum I've tested up to 10, 20, 30. It really just depends on how much you want to actually run this thing and test it. But suffice to say, you're going to have enough headroom to deploy as many as you want. So let's go and actually set that to 3. So what it's going to do now, it's going to actually detect that we've gone from 2 to 3. And what it's going to do is use Terraform. Terraform will know this pretty intuitively to deploy a new Windows server. So you can see that it knows about proxy 0 and proxy 1. But what it's going to go do is effectively go and create proxy 2. So 0, 1, 2, it's got an array from 0 to 2 for 3 in total. And now it's going to go and create that new backup server. So if we go back to the actual vCenter itself, you'll see that the third one's come up and is about to be powered on basically after the cloning operation. So there you go, it's powering on. So again, it's doing all the work for you. This is Terraform doing a lot of the magic here under the covers. So if we go back here, let's wait for this to deploy and then I'll come back and explain what's happening. Okay, so there again. So Terraform about 3 minutes to basically deploy that, and now what you can do is it's detected that the previous ones already existed in configuration, and it's only adding that new one. So this is the scale-up feature of the auto-deploy functionality of Project Otosukeru. So here we go. So doing the same thing, you've seen this before, but effectively now it's going to add 228 to the list, and it's going to be available for use as proxies of other jobs as well. So let's wait for that to finish, and then we'll look at the scale-down functionality as well. So we'll basically bring it back to 2 proxies at the end here. So this will take a couple more seconds to go through and do its thing. So again, adding it, creating a new Windows proxy, and if it was a Linux proxy, it'd be the same thing. Okay, so there you go. So it's been added. So now what I'm going to do is go and actually run the same command, but going to drop that back down to 2. This is going to be obviously a much quicker operation because it's going to effectively, Terraform is going to destroy the machine. But the first step here is it will detect which one needs to actually be removed. It will remove the older one first. It's got that logic in it. So you can see there we've removed that last one that we've put in. So scaled it down, removing the proxy from backup replication. So it's removing it under the proxies and managed Windows. And then what it will do is it will go and actually call Terraform to destroy that particular VM. So again, this is a very quick function here. It should take a couple of seconds to actually do the destroy. So there's a few modifications that it's doing. It'll do that all the time on the existing ones just to make sure it's all good. Destroying proxy 2, and there we go, we're done. Okay, so that's it. Scale up, scale down. Fantastic. Now to delete, what we can do is we use the same commands that we used to create, exactly the same, but what we're going to do is do a destroy. So this is going to go through and actually destroy and get rid of all of them. So it's got similar logic to the scale down, but obviously it's going to not think about what's in place already between the high value and the low value. It's just going to go and destroy everything that it finds that it's created, basically. So not ones that are in existence, must point that out, one that it's basically created and it knows about. So there you go. So it's removed both of those ones, and then that's done from the Veeam Backup Replication server itself, and then it's going to finish off by destroying the actual virtual machines. So let's go and have a look and see again what vCenter's doing. So there we go. So we'll see these power off in a few seconds and they will be destroyed as machines. So again, this is where the ephemeral usage of it comes in. Spinning up, spinning down, and basically, using the resources on demand. There you go, they're deleted. So this would be ready. Here we go, done. Okay, destroying proxies done. So to spin up takes about 5 minutes, to spin down takes about half a minute. really, really quick. Okay, the next thing I wanted to show here was just quickly touch on the fact that, some of the other options here that we have, we can obviously deploy Ubuntu, we can deploy CentOS here. So that's where that mapping comes into place. And again, it's going to use these parameters and feed it back into the script to do its thing. And also, if we go for Windows, we have the option to have a couple of flags. So by itself, if we're not setting the amount of proxies specifically, it's going to actually do a little bit of logic search within the backup replication server. And within the code, it's got a little bit of logic that basically works out how many jobs there are, how many VMs there are, and then effectively, set a certain number of VMs to match that. It's not exact, but it works pretty well. And that's basically its default. The great thing that we've put in there for hyper-converged situations like, say, vSAN, is I've got a flag in there called set proxies, proxy per host. There you go. So proxy per host is literally going to get the amount of proxies per host. It's then going to deploy the equal amount of proxies that equate to the number of hosts. And it's actually going to apply some affinity rules on there as well, some anti-affinity rules, which means that every proxy we deployed and basically bound to a particular host. So that's pretty cool as well from a vSAN perspective to get, and also that point, VMware Cloud and AWS, very useful from that perspective as well. The last flag that I wanted to show was the NAS proxy, so the ability to basically deploy a NAS proxy if it's a Windows box as well. So that's it pretty much in terms of showing you what it's actually doing. Now the last thing that I wanted to show in this very quick overview is how you actually implement that when it comes to adding it to a job and how you actually do ephemeral proxies per job. So if we go back to the actual configuration, and if we go back to Visual Studio Code, you'll see that down here, I've got this post and pre batch script. Now what this is going to do, it's got a couple of default settings, but effectively what this one's going to do here, it's going to run the PowerShell command. It's actually going to run what you just saw there, but it's going to specify Ubuntu set proxies, and in this case, because it's a post script, it's going to destroy. And if we look at the pre-script, we're going to basically configure Ubuntu proxies and set them to 4. Now where you actually use this is in the Veeam Backup Replication job itself, or replication job, it doesn't really matter which one. Okay, so let's go to the jobs and let's have a look at this one here and let's edit the properties of that. And if we go to storage and advanced, this is where actually we can set some pre and post scripts. So you can see here, run the following script before the job, run the following script after the job. So effectively what I've done is linked to that batch file, which effectively tells it to run a creation of a bunch of machines, 4 of them, before the job starts, and then use those 4 for the job. And then the postscript is effectively deleting that. So think of the resources that we're saving and the ability to quickly and deploy these ephemerally, have them created and destroyed per job. It's quite a cool use case for it. And actually the first real use case that I thought about when I was actually designing this initially before the auto scale came into play. So let's actually have a quick look at this. Let's run this job. And what you'll see here, we don't tell a lot of information in the actual job window itself. But what you'll see here, it's running the pre-job script. And the best way that we can actually tell this is actually happening is if we go back to our vCenter. And let's go to the vCenter here. We should see a bunch of Ubuntu machines. There we go. So 4 Ubuntu machines coming up and running. So they're going to be configured as proxies. They're going to be added to Veeam Backup Replication. So let's wait for this to do its thing actually and see what it looks like from the point of view of the proxies in the Backup Replication console itself, and then obviously wait for it to go through and finish. So let's come back when that's actually completed. Okay, so they're deployed, they're powering on, they're being configured. If we go back here, you can see we're still running that script. Let's cancel out of that. And let's take a look at the backup infrastructure and see how our proxies are actually going. So what we'll see here in a second, and this is one of the great things about V10, and one of the features of Veeam Backup Replication 10 is we added the ability for Linux proxies. And for me, the Linux proxies are a really, really strong example of where you would actually use this because, they're quicker to deploy, consume a little bit less resource and work just as well as Windows proxies. So they've got a really good use case, Linux proxies, for this particular situation where you want to deploy very quickly a number of proxies for the job and then destroy them afterwards in that ephemeral fashion. So let's give us a couple more seconds before it pops up. Okay, here we go. So we can see that we've started to get the Linux icon there. We've got the Linux proxies being added, and they're going to actually be added in here as well. So let's give it a couple of seconds to do its thing again. And we'll have 4 by the end of this process. And then what will happen is when that pre-job script runs, it'll then run the actual backup job itself using those 4 proxies that we've just deployed. So let's give it a bit of time to populate and create that. And again, the one thing to note here while it's actually doing its thing is that you don't need to worry about this. You're actually auto-scaling potentially during a backup window at night. The automatic deployment is taking care of the fact that you're going to scale up and down depending on your particular needs for the jobs. And jobs sometimes need additional proxies. That's obviously for you guys to work out. If a job is running a bit slower, you can always add a proxy to make it quicker. So at that point, you know how many proxies you need for a particular job. So the ability here to set it specific to that job and only have them there using the resources while that job is actually running is, again, quite a strong use case for this. So there's all 4 of them there, and then the backup proxies, we should be adding that 4th one in a second, and then we'll go back to the job and see that the job will kick in and do its thing as well. So there's the 4 that have been added there. And if we go to backup proxies, we should have 4 there now. So if we go back to the job and we see the running job itself, now it's actually going to kick in and actually building the list of VMs that it's going to use, gathering that information. And what it's going to do, because the job is set to basically choose any proxy in the Veeam Backup Replication server, it's going to use our logic, the Veeam logic, to basically work out which ones it's going to do. So in parallel, of course, more proxies, more slots, more ability to add disks to the backup job, you can get through that job a lot quicker. So, again, it took 5 minutes to add those 4 proxies. To be honest with you, adding and taking 5 minutes to add proxies for a smaller backup window is obviously, not a worry. But also, more importantly, obviously the fact that you don't need to have those backup proxies sitting there and consuming resources for, 23.5 hours of the day, those machines. And it's basically going to go and use all those proxy that we've deployed. So just wanted to let this run through, we'll work it through, speed it up, and we'll come back at the end and look at what it did. So you can see here we're using 221, this one's using 223, this one is going to start to use the default one that was in there, so you're probably good to disable that one, and this one's using 220. So again, all of them using slightly different proxies, which is obviously going to help the job get through a lot quicker. Let's just wait for that to power through. Okay, now she's rocking through pretty quickly, moving the snapshots, and then we'll do that last one, which means we probably could actually do with another proxy. I might change this to 5 and it will actually do it a lot quicker, obviously. 1 per VM. Because obviously some of these VMs will have multiple disks as well. In fact, they do. There you go. That's probably why they're. So let's wait for that one to kick in. That should start now because we've freed up the other resources. There we go. Cheeky snapshot present as well, which I'll deal with afterwards. So this one's here is using 221. Now on its own, ready to be completed. Should fly through. Using hot add. Pretty quick as well. Let's wait for that to finish. Now if we go back to the default screen of that job, what we'll see once all those are finished is that we'll see the postscript. The prescript's been run. Afterwards, now that postscript's going to be run, which is going to delete those proxies that we've configured, or that we've deployed, sorry. Okay, now it's running the post job script, so let's go back and see now what's happening on our backup infrastructure, which is see, oh, there we go, the proxy's already being removed. So there we go, 222, 223, they're going to be removed and they will be deleted from VMware itself. So there you go. So a really good example of how to actually apply this for ephemeral use, in addition to the general use, which for me is the bigger use case, which is the automatic scaling of proxies as you go along. So again, a lot of use cases for this. Again, you don't need to deploy proxies manually again with this. It's a great example of using infrastructure as code, Terraform, PowerShell, together with Veeam Backup Replication to do a lot of great automation work with it when it comes to proxies. Download it, clone it, and use it. Thank you.